Hello, and welcome to the lesson on iterative methods. What are the three things we are going to learn in this lesson? First, we'll try and understand what is this process of iteration using some real life examples as well. Then we'll try and find out how do we get the solutions to some higher order equations using the method of iteration. And finally, we'll understand a special method of iteration called trial and improvement. We'll use that to get solutions to some simple questions and also solutions to higher order equations. So let's get started then. If you look at these equations, what do you think? Okay, can you solve these equations? X plus 3 equals to 15. X plus 9 equals to 4 minus 2x. X divided by 7 equals to 2. X squared minus 7x plus 12 equals to 0. And x squared minus 5x plus 6 equals to 2x squared plus 3x minus 3. What do you think? All of these equations look familiar to you, right? And you must have solved these at some point or the other, right? So each of these equations can be solved using some regular methods. Okay, now what do you mean by regular method? In case of linear equation, you can always use the inverse method to solve the linear equation. What do you mean by inverse method? Okay, if there is a plus 3, to counter that you do minus 3 from both sides. If there's a division, okay, divide by 2, you just multiply by 2 on both sides to counter that, right? You just do inverse operation. Likewise, in case of quadratic, okay, you can find solution using 3 different techniques. Okay, you have learned how do you factorize a quadratic and get the solution to a quadratic equation. Then we also learned how do we complete the square. Okay, we've expressed that as a square number plus or minus something, and then we use that to complete the square, and hence we can solve the quadratic equation. Similarly, there was a quadratic formula which you must have learned to solve quadratic equations, okay, which you can easily substitute and get the answer. So all of these equations can be solved by some technique or the other, which are called regular methods, and hence you're familiar with them. However, if I present you with a higher order equation like this, okay, x cubed plus 5x squared minus 2x plus 3 equals to 1. Now, can you think of any regular method to get the value of x which satisfies this equation? Now, unless you know techniques of factorizing higher order polynomials, this cannot be solved and using any normal method, right? So you cannot get an exact answer using a regular method. But what you can do is you can find approximate answer using iterative methods. Okay, and that's what we are going to learn. How do we use iterative methods to get solutions to higher order equations like these? Now, what is iteration? Iteration means repeatedly carrying out a process. Okay, so there's a process, you keep carrying out that process until you get a refined version of the answer, the output. Okay, and that's something which is the best or the refined version. Okay, for example, the iteration works like this. So to solve an equation using iteration, what you do is you start with an initial value, right? You put it into that equation, substitute that into an equation. So obviously you will get a first value, okay, as the output. Now you put that back into the equation, right? And then you get a third value. You put that back and so on. You keep doing this until you find that the values end up being more consistent. Okay, more consistent means they're almost equal or very close to each other. So the minute you start obtaining such values, okay, which means your answer is approximately close to that particular value which you get, right? Now, where do you find iterations in real life? Right? Here are some of the examples which we can see. In terms of music, okay, you will know that a musician may start with one version of a song. So he initially composes a song. Okay, however, that may not be his final version. Okay, he definitely goes on to refine it, makes changes to the notes and the tempo of the song. Okay, and he carries out many different iterations of that song until there's a final product which is created, which he believes is the best, right? So this trial and improvement keeps happening. This is called iteration, right? Until he gets the final product which he's satisfied with, right? Now, this is very common in the software industry, right? So in a software industry, the company may release multiple versions of a software to add functionality for the user, right? To correct the bugs also. Okay, so it releases a beta version of a software so that the users can use it. And in the process, okay, if there is a mistake or the bug which is there, they can catch that and they can get it corrected. Okay, so each different version is a different iteration. The idea is the next iteration should always be somewhat better than the previous iteration. So there's a little improvement in the software every time it goes on for iteration, until obviously it gets into the last and the best for a particular output at the end. This is definitely applicable for hotel industry, right? Where a cook may experiment with a recipe. He keeps tweaking the ingredients, okay, changing different steps of the process slightly until, okay, the food tastes the best, okay, as good as it can possibly can. Okay, so he's satisfied with the taste. So iterations, okay, you can find that is applicable in real life in many modes. Okay, you may do that iteration also many times in your real life. Okay, if you're doing some process, okay, you keep improving it until you get the best version of it, right? So how do we apply iteration for solving mathematical equations? Okay, so here's what it is. We use subscript numbers to show what's going on in iteration questions. For example, x0 is the initial value of the variable that we start the iteration process. Okay, x0. So it's the zeroth value, so as to say, the initial value. Then the output that you get by substituting x0 is your first output, right? It's called the first iteration. So that's output is x1. Then you substitute x1 back into that equation and you get the output as x2 and so on. That's the second iteration. This keeps continuing until, as I said, okay, you keep getting more consistent values which are close to each other. Okay, and there's hardly any difference between these two values. X subscript n and x subscript n plus 1 are used to describe two consecutive terms of the iteration. So n and n plus 1 is obviously the next step, plus 1. Okay, so n step and the n plus 1 step. They are two consecutive steps of the iterations. Right. Now let us understand this using an example. Okay, this is better said than done. Okay, so let's do it and let's understand that. Find the solution to the equation x cubed minus 3x equals to 12 using the initial value, which is x0, as 3. Your answer should be accurate to 3 decimal places. So here's what we can do. Okay, so if the equation is x cubed minus 3x equals to 12, so we need to express one of those x in terms of the other x. Okay, so what we'll do is we'll write it in this form. X equals to cube root of 12 plus 3x. Okay, if you look at the main equation, we can always rearrange that equation, right? If I get the minus 3x on the right hand side, I'll get 12 plus 3x. But on the left, we'll be left with x cubed, right? X cubed is 12 plus 3x. So x will be cube root of uh, 12 plus 3x, right? So what we'll do is we'll keep substituting the value of x into the x which is inside the square root symbol or the cube root symbol to get the output which is x outside the cube root symbol. Okay, so inside the cube root symbol will be x subscript n, and outside the cube root symbol, which is the next output, okay, which is we input the values in x n, and the output that we get is x n plus 1, which is the output to the next iteration, right? So I'll just replace x inside the cube root sign with x subscript n, and the x outside the cube root symbol as x subscript n plus 1. Now let's get started. Okay, so we have been told to use the initial value of x as 3, which is x0, correct? So if I substitute x0 as 3, what will I get? Okay, inside the cube root symbol, I'll have 3 times 3 because that's x0, which is 3 times 3 is 9. 12 plus 9 is 21. And cube root of 21 is your output number 1. Okay, that's why it is x1. Cube root of 21 is 2.758924. Okay, which when rounded to 3 decimal places, because we need the answer to 3 decimal places, the x1 is 2.759. Now, what do we do in iteration? We now substitute this value of x1, which we obtained in the first step, okay, into the second iteration. But I will not take the rounded answer. I will take the main answer, which is around 6 decimal places, which is given. Okay. So in the next iteration, what I'll do is I'll put x1 inside the cube root symbol. Okay. And the value of x1, which I'll put it is 2.758924. That will be inside the cube root symbol. Okay. So 3 times this number, x1, plus 12, whatever that is, find the cube root of that. That will be your x2. So x2 is 2.726882, which when rounded to 3 decimal places is 2.727. Correct? Now, if you look at x1 and x2, they are two different answers. So we still don't have any consistent answer. So what we'll do is we'll substitute x2 in place of xn now, which is inside the cube root, and then find x3, which is outside. So x2 is 2.726882 from the previous step, as you can see, right? If I substitute that in place of xn, then xn plus 1, which in this case will be x3, will end up being 2.722566. So x3 when rounded to 3 decimal places will give you 2.723. Now I substitute that value of x3 in place of xn, right? So I'll get x4 as 2.721983, which when rounded to 3 decimal places will be 2.722. We still don't have the same answer. Okay, if you look at the last column, it's very close, but still we don't have a consistent answer. Consistent means you should end up getting the same answer. So let me do the next iteration as well. So x4 now is 2.721983. If I put that in place of xn inside the cube root symbol, I'll get x5 as 2.721905, which when rounded to 3 decimal places gives you 2.722. And as you can see now, okay, these last two values that we had obtained were the same, which means if I now keep substituting this value, the output will be the same, 2.722, which means you're not improving the answer any further. This is the best possible answer that you can get. And hence, the value of x which satisfies that higher order inequality is x equals to 2.722. Right? Let's take one more example to understand this better. Find the solution to the equation x cubed plus 5x minus 2 equals to 0 using the initial value x0 equals to 1. And you need to give the answer to 5 decimal places. What we'll do this time is rather than making x cubed as the subject, okay, I'll make 5x as the subject and take x cubed on the other side. So what will you end up getting? Okay, so you'll get x equals to 2 minus x cubed. As you can see, minus 2 on the right hand side, if it goes, it becomes 2. X cubed becomes minus x cubed, right? And because we had a 5x on the left, if I divide by 5, I will get x equals to 2 minus x cubed equals to 5. Divided by 5. Okay, so that's what is the expression that I'll end up getting. So what I'll do is in place of x cube, I'll put xn. So the first input will go to that, and the output, which is xn plus 1, will be the one on the left, something like that. So xn plus 1, which is the output of any iteration, equals to 2 minus xn cubed. Xn is the input of the iteration, divided by 5. And as given to us, we first start with xn equals to 1, okay, which will be the 0th value. So x0 is 1, which is what I'll substitute in place of xn. So what will I get? Okay, 2 minus 1 cube. 2 minus 1 cube is 1, divided by 5 is 0.2. So x1 is 0.2, which when rounded to 5 decimal places is 0.20000. Now I'll substitute for the next value, I'll substitute x1 in place of xn. So now x1 is 0.2. So xn plus 1 will be 2 minus 0.2 cube divided by 5, correct? Which is 0.3984. Because this is the output to the second iteration, this will be termed as x subscript 2, x2. Now that number, when rounded to 5 decimal places, is 0.39840. As you can see, the two values that we have obtained so far is not the same. Definitely not consistent, so I'll have to do more iterations. If I do x2 now equal to 3984 and I substitute that in place of xn, I'll get the next output, which is x3, which is equals to 0.387353, which when rounded to 5 decimal places is 0.38735. Because we are not getting consistent answers rounded to 5 decimal places, I'll have to do more iterations. So x3 now is 0.387353. I'll substitute that in place of xn, okay, and you'll get x4 as 0.388376. So x4 when rounded to 5 decimal places is 0.38838. We'll do one more iteration. So x4 now is 0.388376, which will go in place of xn. So I'll get x5 as 0.388284, which when rounded to 5 decimal places is 0.38828. So as you can see, the answers are becoming more and more consistent, but not yet. Okay, 38 and 28. So we'll have to do some more iterations. x5 now is 0.388284. If I substitute that in place of xn, I'll get x6 as 0.388292, which when rounded to 5 decimal places is 0.38829. And now, okay, it's almost the same now. Let's do one more iteration. Let's see what we get. x6 is 0.388292. When I substitute that in place of xn, I'll get x7 equals to 0.388291, which when rounded gives me 0.38829. And now this is the same value that I obtained in the previous step. So I can stop my iteration now. And this is the best possible improvement, because now if I keep substituting, I'll end up getting the same answers to 5 decimal places, right? So I won't improve the answer further. So my final answer for this equation, the solution is x equals to 0.38829. Now be mindful that for these questions, you will be allowed to use a calculator. So if you're wondering how are we getting the answers so fast, okay, obviously we are putting it in the calculator and calculating the answer, right? Now let us have a look at a second technique of iteration, which is called trial and improvement. And let's see how do we apply trial and improvement with this example. Find the value of square root of 70 accurately to 2 decimal places without using the square root symbol on your calculator. So we are not allowed to use the square root symbol on the calculator, but still we are supposed to find out square root of 70 accurately to 2 decimal places. Is it possible to do that? Well, yes, using the method of trial and improvement. Okay, this is how we can do that. First of all, root 70 lies between 8 squared and 9 squared. You all know that, right? 8 squared is 64, 9 squared is 81. So root 70 lies between 8 squared and that is 64 and 81, 9 squared. And it is close to 64, not 81. 70 is close to 64, not 81. So your answer will be closer to 8, right? That tells me an idea or gives me an idea about what should I start with. Okay, so let's start with 8.1, because I know it's more than 8, less than 9, but it is closer to 8. Had it been closer to 9, I would have started at 8.9. Correct? But this time I know that it is closer to the lower bound, which is 8. So I'll start with the value of 8.1. What is square of 8.1? Square of 8.1 is 65.61. Mind you, you can use a calculator for squaring. The only symbol you're not allowed to use is square root. Okay. So we get 8.1 squared is 65.61. And our target is 70. To get 70, right? We are finding root of 70. So 65.61 is a small value compared to 70. So we need to increase 8.1. Let's take the next value, 8.2. What is 8.2 squared? 67.24. We're still not there. We are still less than 70, right? Smaller than 70. So let's take the next value, which is 8.3. What's 8.3 squared? It is 68.89. Still not there, right? We are still not reached 70. We are still smaller than 70. How about 8.4 then? If I do 8.4 squared, you will get 70.56. Now, as you can see, you have exceeded what we need. All right, we needed 70, we have more than 70. So your answer clearly is between 8.3 and 8.4. We need to round the answer to 2 decimal places, remember. So your answer is 8.3 to 8.4. right? So the next set of iteration which I'll do is for 2 decimal places, okay, in 8.3 something. So let's find out with the middle path, okay? What about 8.35? If I do 8.35 squared, I'll get 69.7225, which means your answer is clearly greater than 8.35 because we still not reached 70, as you can see, right? How about 8.36 then? 8.36 squared is 69.8896. It is still smaller than our target value, which is 70, right? So let's increase 8.37. What's 8.37 squared? Now it has exceeded 70, 70.0669, which means your answer is somewhere, it's either 8.6 or 8.7 because now you have reached the upper bound, right? You have reached the higher. Now, how do we decide whether it is 8.36 or 8.37, right? Now, an answer when rounded to 2 decimal places should give me either 8.36 or 8.37. Now, how do we decide that? So what I'll do is I'll find 8.365 squared. Okay, let's find out. The moment I do that, 8.365 squared, you will get 69.97323, which is clearly lower than 70, which means your answer has to be bigger than 8.365. Square root of 70 should be greater than 8.365 because 8.365 squared gives you a value less than 70, 69.97323. Because your answer is greater than 8.365, if you round that answer to 2 decimal places, it will not round down, it will round up. So your final answer will then be 8.37. Correct? So this is how you do trial and improvement to get answers to questions which you cannot solve normal by using normal methods. Right? Let's take one final example. Let's say we have a higher order equation, x cubed minus 2x squared plus 5x equals to 7. Now, we don't want to solve this using iteration, but we'll solve this using trial and improvement to 1 decimal place, right? So as you know, we need to use one value of x to start with or begin with, and then make an improvement. So what if x was 0? If x is 0, okay, the left-hand side of the equation, x cubed minus 2x squared plus 5x, everything will be 0. But we need it to be 7, right? Which means this value is too small. Okay, compared to what we need. We need 7, but this value is too small. So we need to increase the value of x. So let's increase it to 5. Okay, let's see where do we get. So it will be 5 cubed, which is 125, minus 2 times 5 squared, which is minus 50, plus 5 times 5, which is 25. So what's your net value? It is 100. But our target value was 7. So this time it is too high, right? We needed 7 and we have reached 100. So your clearly answer is between 0 and 5. Okay, let's take 2 then. If I put x equals to 2, the left-hand side of your equation will be 10, which is once again very high. Okay, not too high, but yeah, high compared to 7. So we need to lower that, right? So let's use x equals to 1. If I put x equals to 1, the left-hand side is 4. Now I have zeroed in. Okay, so it's between 1 and 2 because we need 7. If I put x equal to 1, I get 4. If I put x equal to 2, I get 10. So your answer is between 4 and 10. And hence, your final answer, the solution will be between 1 and 2. So let's do the improvement now. Okay. What if x was 1.5? Okay. If I put x equal to 1.5, I know I get 6.375, which is smaller than 7. So I need to increase that value. What about 1.6? If it's x is 1.6, then the left-hand side will be 6.976, which is again smaller than 7. We have not yet reached 7. What about x equals to 1.7 then? If I put 1.7, then it clearly exceeds 7. The left-hand side is 7.633. That means my answer has to be between 1.6 and 1.7. So I have zeroed in, right? But what will it be? 1.6 or 1.7? So let me check for 1.65, which is middle of the range value, between 1.6 and 1.7. If I put 1.65, okay, you will get 7.2971, which means it has clearly exceeded 7, which means your answer is clearly smaller than 1.65, right? 1.65, the answer is smaller than 1.65. And hence, when you round the answer to one decimal place, it won't round up, okay? It will round to 1.6. So that's your final answer for this particular equation, x equals to 1.6. Well, that's the end of this session on iterative methods. I hope you understood what are iterative methods, okay? So first of all, we understood, okay, what are iterative methods and where do we use in real life as well? And then we figured out, okay, how do we use iterative methods to get answers to higher order equations, right? And finally, we also learned about that special technique of trial and improvement, okay, which is a special way in which we can do iteration, trial and improvement to get the answers to some of those mathematical calculations and solutions to higher order equations as well, right? I hope you understood the session. I enjoyed bringing it to you. Thank you.